This is GATE 2016 set 2 electrical question number 53. Two identical unloaded generators are connected in parallel as shown in the figure. Both the generators are having positive, negative and zero sequence impedances of J.4 per unit, J.3 per unit and J.15 per unit respectively. If the pre-fault voltage is 1 per unit for a line to ground fault at the terminals of the generator, then the fault current in per unit is being asked. For NPTEL reference, you can refer to lecture number 3, Fault Analysis Review, Sequence Components of the NPTEL course Power System Protection by Professor A.K. Pradhan, Department of Electrical Engineering, IIT Kharagpur. For useful data, you see that for a line to ground fault like this, consider that the fault occurs at line A, then terminal voltage VA becomes 0, the fault current and the line current at that phase becomes the same, and these two currents IB and IC will become 0. Now if we analyze the symmetrical components from the A, B and C line currents, then we find that for a line to ground fault, three symmetrical components are equal to IA by 3. Since the three symmetrical components are equal, we can interpret from these that the positive, negative and zero sequence networks are connected in series such that the three symmetrical components are same. Coming to the configuration for our delta connection, we should remember that the zero sequence component cannot flow in the line but can flow the delta winding like this. For a star connection also, the zero sequence components cannot flow in the line but they can flow if the neutral is grounded, then the zero sequence current can flow. So if I am asked to draw the equivalent circuit for this zero sequence component for a star connection, then if this is the zero sequence impedance, then in line it cannot flow, so this should be open circuit. This is the circuit. If this is star grounded, that is the neutral is grounded, then the line, in line the fault current can appear in the zero sequence circuit. So I can draw like this. This is because the zero sequence can flow in that line. If it is delta connected, then it can circulate inside the winding. So this is Z0. It cannot flow in the line but can circulate inside. So it has a path to flow. This is IA0 and these are the other circuits. So this is the different configuration and their equivalent zero sequence representation. The two generators are there operating in parallel connection like this, where the positive sequence impedance is J.4. These are 1 per unit. So this is the positive sequence impedance network. Drawing the negative sequence network. This, if this is A, then can be B. What can we do like this? J.3, J.3. Since J.3 is the negative sequence impedance connected like this, so this is the negative sequence impedance network. And the zero sequence impedance network, it is star grounded. So for first generator is the zero sequence impedance, which is given to be J.15, and since it cannot flow, the zero sequence current cannot flow because the neutral is not grounded, so we can keep this open, and second one we can be kept closed because zero sequence can flow, and this is the equivalent circuit. Now for line to ground fault, A, B, C are in series. Three circuits shown here. Let's find the Thevenin equivalent of this. So the Thevenin equivalent can be found out by deactivating the active sources, and we see from this side, and VTH with a ZTH and like this. In these two, VTH will be 0. The second circuit, ZTH2 is 0.15, ZTH3. So 2 and 3 VTH 0, ZTH3 is coming out to be J.15. You see from this side, you see J.15 impedance, and ZTH1 and VTH1 are to be determined, where ZTH1 is J.2. See parallel connection coming when you deactivate these two sources by their internal impedances, and you can find J.2 as the Thevenin equivalent impedance, and VTH1 can be determined as the open circuit voltage across this point, which is 1 per unit, because no currents flows, so 1 per unit appears across this point, so 1 per unit. So now VTH1 and this ZTH1, then you connect this with the next circuit, that is B circuit. B circuit is ZTH2 and C circuit is ZTH3. So VTH1, which is 1 per unit, ZTH1 is calculated to be J.2, ZTH2 is calculated to be J.15, and ZTH3 is calculated to be J.15. So for line to ground fault, as determined from the equivalent circuit, the symmetrical component currents, which is IA1, which is same as IA0, which is same as IA2, is coming out to be equal to 1 divided by J.2 plus J.15 plus J.15. So magnitude of IA1 let us calculate, which is coming out to be 1 by 0.2, which is 1 by 0.5, which is 2 per unit. Now we know IA0 equal to IA1 equal to IA2 equal to IA by 3. Now IA is fault current, so the fault current is coming out to be 3 times IA1 to be 3 times 2 per unit, which is 6 per unit. So the answer is 6 per unit.